Awesome. Okay, welcome to part 2 of week 5 in Intro to C++. We're just going to get into PowerPoint 19 and talk about controlling program flow, which is going to be talking about if statements, else, and looping. So you guys seem to have a bit of a understanding of how this works already, but I just want to cover it to make sure any of those nuances or weird things with C++ get covered and talked about. So you can download the PowerPoint from the Weekly Learning Week 5 folder here, number 19, and then any of the code we'll cover is going to be in these two zip files here if you want to download and extract these and then import the project file to your workspace. The first one will be the if-else nests, and then the second one will be the loops file. So everything is there in the week 5. Let's just get into the PowerPoint. Cool. So sequence, selection, and iteration, the building blocks of every programming language, they need to contain all of these things. So ordering statements sequentially, making these decisions, and then looping and repeating. There's many ways to do it, and we use a lot of the common building blocks in many programming languages to do this. So we'll talk about a bit of them today. So a couple things first before we get into all of those that you should be reminded of or understand at this point before we move forward is relational operators. So the equals equals sign means equality if you're comparing strings or values. The exclamation point equals means not equal to, and then obviously you have your greater than, less than, or greater than equal to, and less than equal to operators. A couple other things well, these are just examples of those Boolean expressions. So if you're comparing counter to 5 to see if it was equal to a numeric value, to see if it's greater than a value, and so on. And then testing strings and chars for equality. Remember, we need to do single quotes for a char and double quotes for a string. And then we also have to use the double equals for string comparisons. Cool. So let's talk about the if statement in C++. So if an expression is true, then execute the statement. That's basically how it works. You guys should understand all this stuff at this point. I think you guys would have used this in Java already. And if the expression is false, then it will just skip the statement. And notice the indentation here. It helps read the code. It helps readability, helps other developers, and anything that's tabbed in here will basically say to me, if I'm reading your code, that's supposed to be part of the if statement. So a little diagram of how if statements work. We come down here. This represents a decision module with the diamond. So we're saying if num is greater than 10. So if that condition's true, then any of this code indented underneath will run. So num is greater than 10. So let's say the variable num is 11. Well, that equals true. Or equates to true. So we would come this way and we would do plus plus num. And then we would continue on. If it was false and say we had 9, which is less than 10 and equates to false, then we just move on anyways. Now you might notice it says plus plus num or num plus plus. You can do either in C++. They pretty much are the same thing. And we'll get into this a little bit later, but one's called a pre-iteration and one's called a post-iteration. So if you want to plus plus the number before you use it, or if you want to use the number and then iterate it up, which we'll cover in just a second. More than one condition to execute. So if you have more than one condition, we use a block statement, which is these curly braces after our if statement. And again, represented in this little diagram here. Oh, my screen's going black. That's awesome. We can see that this entire block of code, these two lines, are in these curly braces here. So we plus plus the num, and then we see out something to the console. And if this equation equates to true, then we come down here and we run this block of code, everything in those two lines. And we still indent it for readability. Cool. So just quickly to cover light for an example here, if I come all the way up. So we've got a couple variables here. We've got a const with a min and a const of max, so 10 and 100, and then we're just declaring a variable called num and initializing it to nothing. And then we're going to ask the user to enter a number between min and max, so between 10 and 100. Then I just have a simple if statement here that I'm going to show you guys as an example. So if my num is greater or equal to min, which is 10, so if it's 10 or greater, then everything inside of this block will execute. So we can have multiple conditions inside here, and we can do a cout if statement 1, and then say num is greater than 10 or min, right? So let's just run this as an example. Oh, that's not my active project. There we go. Cool. Nope, still not my active project. If else nests. Set active. There we go. Enter a number between 10 and 100. So if I enter 9, okay, then none of this code will fire because it will only fire if it's true, right? So if I enter 9, we should just expect the program to end, which it does. Press any key to continue and then the program ends. If I run the program again, and remember I'm checking to see if it's greater than or equal. So if I type 11, which is greater than 10, then it will actually go inside of that if statement, inside those curly braces, and it will print the first cout, and then it will say my number that I entered is greater than 10. Now, if I also type 10, because I'm checking if it's equal to, okay, then it will still say 10 is greater than 10. So obviously we could fix that, but that's just a simple if statement there. Secondly, okay, well, I think I might talk about this in the PowerPoint again, but we can use these Boolean operators. Do you guys know the Boolean operators? So you have the and, which is 2 ampersands. You have the or, which is 2 pipes, like this. You have the and or, which you can do. You have the not equals. There's a couple more Boolean operators like that. So sometimes in other languages it's like that, means does not equal. Sometimes it's like this. Sometimes you use that. In JavaScript, sometimes we use 3 equals. So sometimes it can be different, but those are called Boolean operators. I think I talk about it again here. So there we go. Let's see. No, okay. So I do want to cover this one. So if I run this one, let's take a look at the code before I run it. So we've got if num, what the user has entered, so I'm using the same variables as before, okay? If it is greater or equal to the min, but then now I'm also checking if it's less than or equal to the max. So that's what the ampersand does. And num is less than or equal to max. A common mistake that beginning programmers make is they won't include this variable again. So they think in their head, if num is greater to min and less than max, and then that's what they type. If num is greater than min and less than max. But the thing is on the other side of this operand, you have to include the variable that you're comparing that to. So right here it says, I don't know what I'm comparing max to. So you have to say if num is greater than min and num is less than max. So you have to put the variable in twice. Okay, so now it's going to check it and less than 100. Cool. All right. Now, it's going to cout this line and everything in this block if it's true, and then it's going to say the num is in range. So I can leave this one uncommented actually, and then we can run this. And we'll see if I enter something above 10 but over 100, let's say I enter 101, it'll just say 101 is greater than 10. But because it's greater than the max, and I'm checking if it's less than the max, it's just going to skip over this block of code in the if statement. Does that make sense? Because it's greater than max, this equates to false. Even though it's still greater than min, it's also checking if num is less than max. And it will only operate this code if those two conditions are true. But because it's greater than max, it just skips over it. Okay, so let's run it again and let's comply with the rules. Let's give it 50. So 50 is greater than 10 and 50 is less than max. So we should see 2 if statements here. And there we go. We have if statement 1, 50 is greater than 10. And we have if statement 2, 50 is in range. Cool. The last example I want to show you is another Boolean operator, which is the OR symbol. So this two pipes basically means or. So you can check if it is equal to min, so we're using the equal sign, or it's equal to max. So basically in this example, this can be true and the code will run, or this can be true and the code will run. Or they can both be true and the code will run. Obviously, they can't both be true here because uh, we're using the same variable but comparing it to two different numbers. But basically, it says one or the other. If one or the other are true, execute the code in this block. So if I type 10, print out, because we're still comparing it to be equal to the min, and we're still comparing it to be equal to the min here. So it'll still print out all three statements if I do 10, but it should also print out a third statement saying it's right on the boundary. And there we go. As we can see, I printed out right on the boundary if it's equal to the min. So here we go. We have if statement 1, 10 is greater than 10. If statement 2, 10 is in range. And if statement 3, 10 is right on a boundary because it's on 10. Cool. Okay, we'll comment those out. Awesome. Okay, back to the PowerPoint really quick. So if-else statements, we can continue using the if statement, but you can also give it kind of a fail-safe or a catch so that something executes if the expression is not true, else do something else. So if the expression is true, then we'll execute statement 1. If the expression is false, then we'll execute statement 2 in this example. Again, I want to stress indentation here for readability, and if you only have one statement, you don't need those curly braces. You can just enter, and whatever's on the next line will be what's included in the if clause. So here's kind of a diagram of the if-else statement. So you come down and you're comparing num greater than 10. So that's the comparison here. So inside of these brackets, if num is greater than 10. So if it's true, then we're going to operate everything inside of the if, which is plus plus num, which we can see. If it's true, we plus plus the num, so we increment it. If it's false, so else num equals 10, so false, then we will set the variable of num to be equal to 10. And then we meet up and we continue our program after these. All right, so very simple description of the if-else statement. Here's another example of the if-else statement. So we have two examples here. The first one, if num is greater than 10, then we're going to see out to the console num is greater than 10. Else see out num is not greater than 10, right? Because then we can assume if it is not greater than 10, then we should be able to say something like it's not greater than 10, because that should be true. Or makes sense, I should say. So if num is greater than 10, then obviously we would print out it's greater than 10. Else, then we'll print out num is not greater than 10. Now keep in mind here, what if the user typed in like a letter, like the letter B? Well, it'll compare B to see if B is greater than 10, and you might get a compiler error, or it might just fire the else and just say, it's not greater than 10. In which case you'd want to be able to catch that exception. The second example here is we're comparing a variable called health, less than 100, and heal underscore player, which is obviously going to be a Boolean, so either true or false. Then what we will do is set the health of the player back to 100, else we're just going to increment the player health. So you can see how if and else's are very handy. You can also do the same thing where you use a block statement. So if you want multiple lines of code to be incremented or implemented, in your if, then you can put them in those curly braces. So we can see here, if num is greater than 10, if it's true, we come over here and everything inside the first curly braces, so the plus plus num and the cout increment, get executed on the true side. Then in the else, everything inside of the else, so we've got curly braces, num equal to 10, and cout reset, will get executed if it's false. Cool. So let's go to CodeLight again and do some quick examples of if-else statements. So again, I'm going to use a couple variables here, int num and a const int called target. And the target is going to be set to the value 10. So I'm asking the user to enter a number, and it's going to be stored in the variable num. And if the num is greater than the target of 10, then I'm going to print out num is greater than target, right? So that's just an if statement. So let's run that. We've already done if statements, so there should be nothing fancy here. So if I enter 11, it's going to say 11 is greater than 10. Now, let's continue. I'll uncomment these. So we can see we've got 3 if statements here. So if it is greater than or equal to the target, we'll print it's greater than. If it's less than or equal to the target, we'll say it's less than. And if it's equal to the target, we'll say it's equal to. So I had to use 3 if statements to accomplish this task. And if I enter the number 9, it'll only print 9 is less than 10. If I enter the number 10, it'll actually equate to all 3 of them being true because I compare it with the equals operator. So it'll actually print all 3 statements. Now, why am I showing you this? Well, we just covered if statements, right? If I comment that out, if we come down here, we can do all of that in one if else. So here we've got if num is greater than or equal to the target, then we print out it is greater than, else it is less than. All right? So here we go. We can run that, and everything happens in the if-else statement. So it's entering a number, and we say 11. 11 is greater than 10. Let's run it again, and say we enter 9. 9 is less than 10. So it triggered the else there, right? Cool. Now, you might already be ahead of me, but you can also add another if inside of an if statement. So you can do an if else if block statement. So you can have multiple conditions. So here we can see I compared if it's greater than, else then I'm just assuming it's less than. But what if it's equal to? If it's equal to, I can't fit that condition in here, right? So that's where the if else if comes in handy. So it's even a little bit better because you can have more than one condition you check for. So in this example, we have an if statement that checks if your score is greater than 90, then it will see out to the user a grade of A. Else if the score is greater than 80, it'll see out to the user a score of B. Else if the score is greater than 70, it'll do C and so on, 60 for D. Else, that's kind of the catch-all. So, right, this last else, basically if none of these are true, this is a catch-all statement at the very end where no extra checks will be performed, and we'll just run this, and we'll just give an F, right? So let me show you an example of that. So again, we've got our num. If it's greater than the target, notice I'm not using the equals comparison anymore, then we will print this if statement and say it is greater than. Else if, okay, so you add an if. Instead of just saying else, you add an else if. The num is less than the target, then we print out num is less than. Else if num is equal to the target, then we say num is equal. And then at the very end, we can add kind of a catch-all else, and then we can see out maybe error, right? And then because obviously if it's not greater than or less than or equal to, then who knows what happened, and it will just say error. So let's run this code, and let's see if that works. Enter a number. Let's do 11, and it's greater than 10. Let's run it again. Enter a number, 9, that's less than 10. Let's do it one more time, and let's enter 10 to see if the equals works. So this 10 is going to say 10 is equal to the target, which is set to 10, and it should print out it is equal then, which is improper grammar. But it will say it is equal then 10 probably. Oh. This is not running. Let me just rerun this. I'll enter 10, and as you can see, it says 10 is equal then 10, which it should just say equal to 10, but obviously I didn't catch that grammar. Oh well, okay, back to the PowerPoint. So that's an if-else-if statement. Now, you guys also might already know about nested ifs. Give me a thumbs up or a little party emoji if you guys already know about nested ifs, if you guys have covered these before. We'll just cover them really quickly again with C++. Cool, okay, so a couple of you guys have used nested ifs. Awesome. That's good. So you guys have experience. Nothing to be scared of. But basically, you can have an if condition inside of another if condition. So if the if statement is nested within another, you can basically test multiple conditions. And the rule that how it works in C++ is the else will belong to the closest if. Okay. So indentation is really important here because it allows you to keep track of which else and which if and which expressions are being evaluated and which statements belong to which conditions. But you also need to know that the way C++ evaluates it is the closest else to the closest if belong to each other. So if expression 1 is false here, nothing will run. It will skip all of this code. If expression 1 is true, then it will go now and check expression 2. Okay. Now in this expression, you see we only have one else and two ifs. We call this a dangling else problem. Okay, it's different in each programming language, but in C++, the else belongs to the closest if here, so we know it's this one. But if you don't have a second else, some compilers might not even compile because they might say there's no other else, or which else does this belong to? Cool. So here's another example of a nested if statement. So we can check if a score is greater than 90. And then inside of that, we can check if the score is greater than 95. We can set it to A plus. Else, if it's just 90, obviously we can set it to A. And then have another else at the bottom here. If it's not greater than 90, then sorry, no A. So here's kind of how a nested if would be visualized. So we have our first condition, if score is greater than 90. Remember, if it evaluates to false down here, we skip all of this. So we skip the entire inner if. Now, if it evaluates to true, we come to the second condition in this blue diamond, and we evaluate if score is greater than 95. And if that's true, then we see out the code that is tabbed in underneath the if. If it's false, we do a see out of just A, not A plus. And then we go back to running the code. Another example here, if you're comparing scores, you could have a first condition if Frank's score is not equal to Bill's score, then basically we can now check if Frank's score is greater than Bill's score. Then we can say Frank wins, else Bill wins, else looks like a tie, and we can evaluate all of that in one. So let's just do another quick example here. Coming down to nested ifs. So if we want to use that program that makes user grades, which was kind of the example we used, we come down here and we run this. Okay. So we want to have a program that allows you to enter your score on an exam and go back based on the number you entered. Okay, and if it's over 100 or below 0, then it's out of bounds. So we can see our first if is checking if it's greater than or equal to 0 and score is less than or equal to 100. Then everything inside of that is a nested if, right? Because now we have if the score is greater than 90, we print the letter grade A. Else, if the score is greater than 80, we print the letter B. And that's all nested inside of this outer if, okay? We're using score as a variable of int that the user enters, and then we're printing back the char letter grade and setting it to A, B, C, D, or F, and then printing out your letter grade is, and then whatever it was set to depending on which if statement triggered. All right. If the letter grade is equal to F, then we just print, sorry, you must repeat the class, else we say congrats. Okay. And then this else, okay, if I click this bracket in CodeLight, you can see it belongs to that if. And this is where the indentation is important, because if you lose track of which else and which if belongs to what, then I can just click this and I can see if the score is greater than 0 or less than 100, that's the else that this belongs to. So basically it's going to say, sorry, score is not in range. So say I enter 101, it's just going to go right to here and fire this code. So let's run this and let's do a couple iterations just to see how it works. So it's asking me to enter a number, right? And, oh, sorry. I'm going to comment out these because that's the old one. And we're going to run this. Enter your score on the exam. Now, if I enter 101, it should just skip the entire program, come way down here and say, sorry, not in range. right? Anything over 100. And look, it does. Sorry, 101 is not in range. So the same thing should have to enter, what is it? Whoops. The same thing should happen if I enter something below 0. So if I do -1, it'll say, sorry, -1 is not in range. Now let's enter a real score. Let's say we got an 85. We got an 85. Let's say your letter grade is B, congrats. So it came down in here, it validated that my score was over 0 and less than 100. It checked if it was 90. Obviously that was not the case, so it went to the next else if, and 85 is greater than 80, so it set my letter grade to B, and then it print out your letter grade is B, congrats. Cool. So that is a nested if statement. Cool. Have you guys used switch statements before? Yes. Okay, cool. So switch statements probably very similar to how you use them in Java, but you have your switch and then you have your cases, okay? Now, basically, when the value of the control expression, which is the switch statement here at the beginning, matches the value of a case expression, then the code at that case is executed. Now, it's also got something called a default statement, which is similar to the catch-all in the at the end of those if-else statements. So this will execute if none of these cases are matched. Okay, so an example of a switch statement, and we could have used a switch statement in the last example, and we will get into another example of how to use a switch statement. Here's a quick example. So we're going to do a switch on a variable called selection. And selection is an int in this example, and it can either be 1, 2, 3, 4. And if it's not one of those numbers, then the default switch case will run, which will say 1, 2, 3, 4 are not selected. So if I put in 5 and that won't trigger any of these, the default will run. Now say I entered 2, then my switch case 2 will execute and be triggered, and cout 2 was selected. All right, so very similar to an if else, if else, if else. Just depends on your scenario and what you're going to use. Now, a fall through example is if you don't have this break statement here. So you'll notice in each of these cases, except for case 3, there's a break. All right, so it says cout1 selected, break. cout2 selected, break. The reason we have that break statement is because it will exit the switch after that case is executed. Now see here, 3 has nothing, so then it will just fall through to number 4 and say 3 or 4 was selected. So here we have something called a fall through example where there's no breaks in case 1, 2, or 3. So it'll run all of these. It'll just fall through until it hits the next break. All right. This is not best practice. Okay. It'll execute every single case until it hits a break statement. So best practice is to include a break in every single case statement. Okay. Now you can also use a switch on an enumeration type. So we made an enum called color here, and we're giving it the values red, green, and blue. And then we're setting, because we just made this enum of color, we can make a variable of type color because of the enum we declared. And then we're calling the variable screen underscore color and initializing it to green. So we're going to switch on screen color. And this is very common, okay? It's very common to see switch statements on enums because you can define what you want to be in the enum. It's basically like creating a mini object, right? So we can switch on the screen color, and if it matches green, it'll cout green. Now the default should never execute here because it can only be red, blue, or green. Now if we added a color to this and we set it to be orange, then maybe the default would execute. But in this example, the default should never execute. All right. So a couple things to keep in mind with switch statements. The control expression must evaluate to an integer type. So the control expression is basically the top thing up here. Unless obviously you're evaluating to like a Boolean or something like that. Like in this case, they're evaluating to a color. So then they're doing case red, case green, case blue. The case expressions must be constant expressions that evaluate to integers or integer literals. So they just have to be something that won't change, right? So case 1, case 2, case 3. Once a match occurs, all of the following case sections are executed until a break is reached, and then best practice is to put a break in each case, and then the default is optional, but it should be handled, okay? So let's go back to CodeLight and do a quick example of a switch statement here. Okay. So it looks like a lot of code, but same kind of idea here. We're going to get some input in the form of a char. Okay, so instead of getting them to enter a number here for their grade, I'm going to comment that if else out, and we're going to enter them to enter a letter. Okay, and then we're going to take it in our cin, and we're going to test for both cases of lowercase a and uppercase a. Okay, so we're switching on a variable called letter grade, which is the char that they entered, and we're going to switch on that and have cases for lowercase a and uppercase a. And this is, again, you're tabbing in here, and then we're adding this break. Otherwise, we'll fall through. So we're going to see out that you need a 90 or above to get A in this course. Now, if they want to get, it's asking what letter they expect to get on the exam. So if they enter B, then we're going to see out you need an 80 to 89 for a B. If you want a C on your exam, then we're going to see out you need a 70 to 79. Now, if they enter D, we're going to see out something like you should strive for a better grade. You only need a 60 to 69 for a D. And if they enter an F, okay, let's ask the user if they're actually sure if they wanted to enter the letter F on purpose. So what we can do inside this case is we can add a curly brace here, okay? Now we only need this because we're declaring a variable in the case. So we need those curly braces. If we weren't declaring this char confirm variable and initializing it in here, we wouldn't need this, right? Because we have multiple lines here, and it's fine because there's no variable declared. But here, because we're declaring this confirm char, are you sure you meant to enter F, yes or no? And then we cin on confirm. If confirm equals y, lowercase, or that's what the two pipes mean, confirm equals uppercase y, then we will see out to them, okay, I guess you don't have to study because they meant to enter the F. Else if confirm equals, right? So we're using our else if here. If it equals lowercase n or uppercase n, good, go study hard then. And then else, this is our catch all, we're going to say illegal choice. So say they enter the letter F or Z or Q. Then we're just going to say illegal choice, and then we're going to break. And then the default statement, this should probably not execute, but if they enter like the letter G or something, we're going to say, sorry, that's not a valid letter grade. All right, so let's run this. We went through the code. We know what we should be able to expect here. Enter the letter grade you expect to see on the exam here. So if I enter an A, it's going to say you need a 90 or above, go study hard. Now let's try the F. Let's try the F statement, okay? If I enter an F, it triggers the are you sure you meant to enter that? Now if I enter a Y, a lowercase y, it should still handle that because I'm seeing if my confirmed char matches, and it says, okay, I guess you don't have to study. Now let's go back in. Let's enter F here. I want an F. Are you sure you meant to enter that? I'll say no. And it says, good, go study hard then. And now let's enter an illegal option, okay? Not inside the letter F, but like right from the get-go. If I enter a G, it'll catch in the default case and say, sorry, that's not a valid letter grade. Cool, so that's operating as we'd expect. Sometimes switches are more code than an if-else. As you can see, they're both pretty long. It's really dependent on you as a developer, what you prefer, and what might be easier or less or more code to develop in that example. But I'll comment this out for now, and we're going to do another example of a switch statement with an enum, okay? So coming down here, I've got an enum called direction, okay? So I just named it direction, and I gave it four variables or types that it can be. So it can be left, right, up, or down, all right? Now, we're going to set, just going to comment this, we're going to set a variable to be of type direction. So just like you would make a variable called num and make it of type int, okay, so you could do int num. I'm doing direction, so it's going to be of type this enum, direction. You see it's highlighted there. And it's going to be called heading, and I'm going to initialize it to be left. So it's going to be the first value in there. Now I can make a switch on the direction that I'm heading. So on that enum, I can make a switch on these. Now it's going to say left, right, up, down. Now, in this example, our cases have to be matching to what's inside the enum. So they have to be left, right, up, or down because of how we declared our enum here. Now I've got case for left, and I'm going to say C out going left, and then I break. And then I'm going to have a case, I actually typed this wrong here, a case for right, and I'm going to see out going right, okay, and then I'm going to have a break. Now you're going to get a warning here because if we don't handle all four cases, so the up and the down, for our enum constants in the switch, then we're going to get a warning saying, you didn't include a case for up or a case for down. Now, if you use a default, I think we can avoid that warning because that will handle all other cases, right? That'll be your default or your catch all. So if I do control F5 here, I don't get a warning. But if I got rid of my, and we can see it's going left, obviously, because I set it to be left. If we got rid of our default here and we run it, you can see that warning, enum value up not handled in switch. Okay, some programs will actually give you an error. So just keep in mind, you have to either do all of these or include the default. Okay. Comment that back up. Back to PowerPoint. Cool. One last thing. Do you guys know or have you guys used the ternary operator? I know I mentioned it earlier this year. It's another way to evaluate a Boolean expression. If you guys have experience with this, I can kind of go a little quicker, but it can be confusing. Basically, you have something called a condition expression, okay? And this would be what would be in your if statement, okay? Now, if that evaluates to true, then expression 1 will be returned. And if this evaluates to false, then expression 2 will be returned. Okay? So it's very similar to an if-else if construct. It's called ternary operator, and it's very useful when you want to use it in an inline to print something out and you don't want a very big if statement. It's very easy to abuse them, though, and you can make them very messy or you can use them incorrectly. So you want to use them sparingly unless you really understand what you're doing. Basically, this conditional operator in brackets is evaluated first, and it must result in either a Boolean value, so a true or a false. And it's basically like an if-else, but all in one line. So here's an example. We have an int a that's initialized to 10, and an int of b initialized to 20, and an int of score initialized to 92. And then we also have result, which is just empty. So we're checking if result, okay, if a is greater than b. So here in this example, 10 is not greater than b. So then after the question mark, remember, the first one will be returned, condition 1, or sorry, expression 1 will be returned if this is true. But because this is false, b will be returned. Okay? Now, in the second example, if a is less than b, which it is, then return b minus a and set it to the value result. So you can see here, I'm going to try to annotate this because it can be a little bit confusing. We're setting the variable. I can't draw because my screen goes black every now and then. We're setting the variable result on the left-hand side here to whatever is returned from the ternary operator. So you're either going to get expression 1 or expression b that's going to be set to the result. So in this example, result will equal b. In this example, a is less than b, which is true, which means expression 1 will be returned, which will be b minus a, which would be 20 minus 10, which would then be 10, which would then be set to result. Okay, so it's very handy if you want to use it all in one line. So 10 will be the result. In this example on line 3, we're checking if b is not equal to 0, okay, and if it's not equal to 0, then we do a divide by b. Otherwise, we return 0. And this is a very handy way of avoiding a divide by 0 error. So if b is equal to 0, then what will happen is we'll just return 0 in the result. Otherwise, you can't divide by 0 and you'll get a runtime error, right? So we can do a divided by b as long as b is not 0. So if this result, if b say b is 3, 3 does not equal 0. So that's true. So then A will be divided by B. So if this was 9 divided by 3, then result would equal 3, right? Okay, and then the very last one is a way of giving feedback to the user conditional on what's inside of this condition. So if the score is greater than 90, then give back the feedback excellent. Now, if score was, say, 80 or something and it's less than, then just give the feedback good. Right? So if it's true, we return this. If it's false, we return the second expression. Cool. Cool. So I'm going to show you guys an example in Code Light again of a ternary operator or a conditional operator, whatever you want to call it. All right. So we have a int called num, and we're initializing it, and we're asking the user to enter an integer and saving it in that variable. Now what we do in an if statement is we modulus 2. So if num is divisible by 2 and it's equal to 0, then we're going to say that num is even, else it's odd, okay? And then this will run no matter what, okay? And this is after the if else. So we're going to say num1 is even or num1 is odd. And then, actually, I should comment this out because this is basically, this one line of code is doing the same thing that this 4 lines of code is doing. So that's the power of the ternary operator. So let me show you the first iteration that we understand with the if statements. So if num is divisible by 2 and equal to 0, okay, then we will say it's even or is even, right? Now if I run that and I put in a 3, 3 is not divisible by 2, which would mean 3 is odd. Okay, now I can comment this out and come down here. Oops. All right, and basically the same thing. We're having this condition, which is the exact same condition in our if, num divisible or mod 2 equal to 0. And then if that's true, we print even. If it's false, we print odd. And then we're just appending it to a cout statement saying num is, and then we're going to either do even or odd, right? So exact same statement, just doing it in 1 line versus in 4 lines. So here we go. We enter 4 and say 4 is even, right? And that's using the ternary operator. Awesome. Okay, I think this is a good spot to take a break before we get into loops. So if we want to take a 10-minute break, come back at around 12:30 roughly. I think I'll pause the video here. Stop the recording.